Hello everybody, and welcome back to yet another video on IB Math. This time we're tackling question 5, and it's actually a two-parter, which we will discuss in this one video. It's not going to be broken up into two parts. Anyways, part A asks us to show that sine of 2x plus cos of 2x minus 1 is equal to 2 sine of x times cos of x minus sine of x. And part B says, hence or otherwise, solve sine of 2x plus cosine of 2x minus 1 plus cosine of x minus sine x equals 0. For 0 is less than x is less than 2 pi. It looks like a very complicated question at first glance, but you can see how these two-parters, like IB really tries to make it easier for you by telling you what equation you should be using and also how to simplify the second one using this equation. And I'll go more into depth about that later on in the video. But first of all, let's start with question 5a. And it's a show that question. And usually when there's a show that, I like to think left side, right side if there's an equation. So we will go for that. Now the left side is equal to and I wanted to show that it's equal to the right side, which is 2 sine x times cos x minus sine x. So the first thing that I kind of think about when I see this kind of question is, are there any trigonometric identities that we can use? I see a sine 2x and I see a cos 2x. So I kind of think, let me do this like kind of off to the side. Sine of 2x is equal to 2 sine x cos x, and cos of 2x is equal to, well, quite a lot of things. One of the things is cosine squared of x minus sine squared of x. So if you applied Pythagorean identity on this, you would get either this or this. So I think any one of these formulas we could technically use in order to show that the two sides are equal to each other. But I think I am going to try the top one first. So here we have 2 sine x cos x plus cos squared of x minus sine of x, sine squared of x, and then minus 1. Actually, I think I changed my mind. It seems like it's easier if you use the last equation, and I will explain why in a second. But just first of all, let me write this down. 1 minus 2 sine squared of x plus or minus 1. And here, so the reason why I decided to change the equation that I'm using is because if you look here, if you were to expand out this thing, then you would get 2 sine x cos x minus 2 sine squared of x. And if you look at the equation right here, with sine of 2x, we already kind of have this first term, but we don't have the second term. And if I were to use the cos squared of x minus sine squared of x, like I was thinking of before, we would end up with a cos squared of x somewhere in that equation, and that wouldn't be good. Because there's no cos squared of x in this equation right here. And so that's kind of why I chose the different equation, or the different identity, if you will. So continuing on, these ones cancel out, and then we have 2 sine x cos x minus 2 sine squared of x. And this is actually very, very similar to what we have up here. But all we have to do now is factor out a 2 sine x and we basically just like have the same identity that's on the other side. So right side equals 2 sine of x cos of x minus sine of x. I should probably also label that this is question A. And yeah, we're basically done with part A. Part B says hence or otherwise. And usually when a question says hence or otherwise, they're asking you to use some knowledge that you have from the previous part. But the otherwise is saying that if you don't want to do that, you don't have to. But I strongly recommend that you actually do look at the previous part, because that could help you a whole lot in trying to determine the answer to the next part. So from the previous part, we know that sine 2x plus cos 2x minus 1 is equal to 2 sine x times cos x minus sine x. And so we can basically just substitute that in. And right away, I see that we can factor out a cos x minus sine x. So let's do that. So now that everything's in factored form, you can split the equations into two because of the null factor rule. So we have 2 sine x plus 1 is equal to 0. And we have cos x minus sine x is equal to 0. And now we can kind of simplify both sides a little bit. So we have 2 sine x is equal to negative 1. Sine x is equal to negative 1/2. And that's kind of the furthest that we can go there. Here we can do cos x is equal to sine x. And here we can do this is equal to 10x, and this is 1. And basically all I did was I just divided both sides by cosine x. And now that we have this, we can finally solve for the angles in radians. So cosine x equals -1/2. It might be helpful to draw a little graph. So we know that arc sine of -1/2 is equal to pi over 2. So this would be 11 pi over 6, because the total of 2 rotations would be 12 pi, and if you go back 1 pi, then you have, if you go back pi over 6, then you have 11 pi over 6. And then this right here is also pi over 6, more than half, so that this would be 7 pi over 6. So those are the two x values for sine x is equal to -1/2, 11 pi on 6, and 7 pi on 6. And for the other one, tan x, we can kind of see that tan x is equal to 1, and the only times that tan x is equal to 1, if you like draw it out, the only times it's equal to 1 are when it lies on this line. And so this is going to be pi on 4, because we're thinking of the 1 over root 2 triangle. And this is also going to be pi on 4. But pi on 4 plus 4 pi on 4 is actually 5 pi on 4. So here we have x is equal to pi on 4, 5 pi on 4. And it turns out those are all the answers that we have for this question, because it's only asking us to go up to 2 pi from 0, and I think we have found all of them. So yeah, that's the end of this question. I hope you found this video helpful, and see you in the next one.